Good morning, SE student. This is your math teacher, Miss you all. Hope you are all safe. Our lesson today is about compound interest, which is used in bank or whatever. In fact, the compound interest is used for long-term loans or investments. As I said, the banks usually deal with this kind of interest. So, in brief, compound interest includes interest not only on the initial investment amount, but also on the accumulated interest. So the interest is on the original balance and also on the interest after the first period, earned after the first period. What do we mean by this? As an example, assume we will save $1,000 in a bank with an annual interest rate equal 6% compounded annually. Now, the original balance here, I have $1,000. The interest after the first year is 6%, which gives us $60. So the new balance, or the balance at the end of the first year, is $1,060. At the beginning of the second year, I'm not going to deal with the original balance. No, I'm going to deal with this balance, the balance at the end of the first year. So the interest for the second year, it will be 63.6. This interest is not only on 1,000, but it's also on the interest earned here, 60. So we have $60 on the original balance, and on this interest we have also interest, which is a 3.6. So the new amount, or the new balance at the end of the second year, it will be $1,123.6. Balance at the beginning of the third year, this one, it will be the balance at the beginning of the third year, which is $1,123.6, which gives us $67.42 as interest. Then the final balance at the end of the third year, it will be $1,191.02. If we are dealing with simple interest, then after the first year we have only $60 as interest, and also after the second year we have $60 interest, and after the third year we have $60 interest, because the interest is only on the original balance when using simple interest. Then the final amount of money, or the final balance, will be, when using simple interest, $1,800, while using compound interest we obtain $1,191.02. Now, how I'm going to find the formula of the compound interest? Assume we will save, as I said before, $1,000 for 3 years and $1,000 for 3 years, and at an annual interest rate 6% compounded annually. For the first year, as I said before, we have $1,000 plus 1.06. What do we mean by this? Here I have 1,000 plus 1,000 times 6% after the first year. So I can factorize by 1,000. It will be 1 plus 6 over 100. That gives us 1,000 times 1.06. And this is the obtained formula. So the new amount, it will be $1,060 after the second year. In fact, we have 1,060 times 1.06, as I said, which is this formula. So in fact, I can replace this quantity by this quantity. So I have 1,000 times 1.06 times 1.06 gives us 1,000 times 1.06 exponent 2, and this is its value. Also, when we multiply for the third year this quantity by 1.06, it will be 1,000 times 1.06 exponent 0.3, as shown in this slide. Writing in a more efficient way, we can say that 1,000 times 1.06 times 1.06 times 1.06, which is equal to $1,191.02. So I can simply write it like this, and as I said before, this quantity is equal 1 plus 6%, which is 1.06. For this reason we use it. Now this is the future value, which is $1,191.02, and this is the present value, or the principal, the actual value that we borrow or we put at the first time, which is $1,000, and this is the interest, and this is the number of periods. So we can say in this case we have here 4 unknown. The 4 unknown are, as I said, the future value, the present value, and I have I, which is the interest rate, and here and the number of compounding periods. If we know any 3 of these 4 unknowns, so we can calculate the 4th one. Now find the accumulated amount after 3 years if 1,000 is invested at 8% an annual interest rate percent compounded. If it is annually means yearly. If we say here annually, this means per year or yearly. And semi-annually, which is half of a year, each half of a year. Quarterly, each 3 months. Monthly, 12 months per year we have. And daily, we have 365 days if it is a regular year. And it will be 366 days if it is a leap year. Now, in the first case, we have annually. So I can use this formula, which is A, which is the new value, or the as you say, the future value, and P is the present value, R is the interest. Since we are here dealing annually, so it will be equal 1, and N is also equal 3 since we are dealing with 3 years. In the second, and we obtain this value at the end by calculation. Now, if, as I said, the present value is 1,000 and the interest equal R, but I'm going to divide it by the number of periods because we are using compounded semi-annually, then the interest is obtained twice per year, so we divide by 2 here. And the number of periods, since each 6 months we have the interest on our account, so in 3 years we have 6 times the interest is add to our account, we obtain this value. Now, here, what if it is compounded quarterly? The main idea, quarterly, and each year I have 4 times the interest, so the number of periods is 12 times, and the interest I divided by 4, so we obtain also this value. The idea here is to substitute. The main idea, in fact, to know how I'm going to determine I and how I'm going to determine the number of compounded periods. Also here I have it monthly, you can use this. Daily, as I said, we can use 365 for a regular year and 366 days for leap year. And this table shows how we are going to use divide by 1 or by 2 when we have semi-annually, quarterly, monthly, weekly, daily, and even per hour. That's all for today. Thank you.